All right, good afternoon, everyone. Sorry for being a little bit late today. My uh, my oldest child had a performance to give, so I was going to support him in doing that. But we scheduled it so that I can make sure to still have this class. So, uh, so here's one thing I wanted to cover today. So we're going to finish inheritance and polymorphism today. I want to cover, though, a couple of things because I'm getting some questions about the assignment, and I want to make sure, since it's so close to being due, I want to make sure that all of you are clear about what is expected. So what I'm going to do is I'm going to show you, I'm going to go through the assignment, a couple of key points that people have been emailing me about, and I'm also going to show something on the some Java code that's shared in the drive, that's shared in the class materials folder that you'll be able to take a look at. Okay, so let's talk through a couple of things. Let's see. I explained the screenshots last time, so I hopefully don't need to go through that again. Let's see. So a couple of you have been asking about what to do, the default value versus the error, the runtime error. You can generate any kind of runtime error. Okay, anything that abnormally stops the program. Now, it cannot be a system.exit. Remember one thing I said last time. If you put a system.exit into your code, most likely your code will get a 0 points on this assignment. Okay, that needs to be absolutely clear. Okay, some of you put system.exit. There were a few. There were like I went and counted in the entire lecture examples folder from last semester. There were like 5 or maybe 6 examples from the textbook Java code that had system.exit in it. It is an abnormal way to normally end a program. We don't do that. Okay, so if you do that, the way that the automatic grading system that runs test cases to determine the correctness of your execution, if you put a system.exit in there, most likely it's going to mess up the system. Not in a bad way, like you're not like hacking the system, but it's going to mess up your grading of your assignment, and you'll probably get 0 points on it. So I don't want any of you to get 0 points. So please do not put a system.exit in there. Okay, but if you are of the group that when an invalid value is passed, such as department string and it's 5 characters or it's 2 characters or whatever, then you need to have the code run a runtime error, create a runtime error, not catch a runtime error. Some of you have been asking me, oh, did I do this right? No, it has to end the program. It cannot. It's not enough for you to do a system that I'm not saying display anything. Don't display anything. Okay, it needs to be a runtime error. You should have gotten plenty of runtime errors in your coding in the past. You know, I would imagine many of you know the kinds of things that cause runtime errors. Okay, the kinds of things that can happen that could cause a runtime error. All right, so throw new exception. It could work. But I think you're getting into exception handling stuff and exceptions that we haven't covered in this class yet, and so the way that Taha is going to be grading these things, that would probably be a question for him. Okay. All right. Okay. Right. So Osla, let me answer your question first. I don't remember off the top of my head which one I said, but one group is giving a default value and one group is generating a runtime error. Generating a runtime error it's one line of code. You should be able to do that using one line of code. One thing I suggested last time was that you create a method, call it something like create runtime error or something, whatever, and just call that method. And that method, and inside of that method have a line of code that its only job is to do a runtime error. Okay. So yeah, so it needs to do that runtime error. Let's see, what should I use as ID and number? Yeah, it needs to be a long Google search. What? Because someone else had a problem with that, and that was it's you cannot just put a number as is, and you should check out Stack Overflow has an entry on that one, Emre. Emre Kaya, an IDE cannot predict a runtime error. It can only predict a compiler error. I think you're getting those two confused. Runtime error is something that happens at runtime. If you do it in the way that I'm suggesting, then the compiler will have no clue that it's actually going to be an error when it runs. Okay? All right. So let's see. What else? Let's see, there was, oh, as far as the naming of variables, we're going to go into that one because this one's going to be a fun one for me, I think. Is some of you have been asking, well, you named it ID here, but shouldn't it be lowercase I, lowercase d, since it's a variable? Look, these up here are just telling you what the attributes are. It's not telling you exactly what you have to name them. The only thing that's important as far as naming is concerned are the methods. Remember, one of the things we're talking about with this whole object-oriented programming is all of our attributes should be private. Our user, the person using our class, should not even know what these attributes are, shouldn't know what attributes we have. The only thing they should know about are what methods we have. So the only thing that's important is you have to make sure you call the methods according to the name that's given here in the assignment description. Okay. Okay. Oh, and one other thing, since teacher is going to extend person, right? Since it's going to be a child of person, do not recreate these attributes inside of the teacher class. All right, they'll exist in the person class. As soon as you say teacher extends person, teacher automatically gets all of these attributes. Same thing with student and grad student as well. Okay, let's see. Is there anything else particularly? I don't. Oh, one other thing that some of you had questions about. So where it is here, number. I called it ID here. I called it number here. You guys know, you probably use student ID, student number interchangeably. They mean the same thing. Okay, again, what you call this variable, not important. What you call this method is important. Okay, so number and ID are the same thing. All right. Okay, so let me go ahead and share my Java screen with you. Let's see what's the question here. Let me take a look. Teacher long ID long int. It's a long integer type. Okay, it's one of the primitive data types. I'm not sure why you would need to do that, Arjun. Considering if you can explain the difference between those two and why one would be better than the other, then you can. I don't know why you would need to do that. I don't know why you would need to use protected instead of private, but you know, you may understand something that I don't about the difference between those two visifiers. So if you can explain why you would need to use one over the other, and the only reason I could think of would be that the child class could gain access to the variables directly, but we wouldn't want to do that. We don't want our child class to have access to our variables directly. We want them to do just like everybody else, and we want them to use the methods, the get and the set methods, to be able to access those variable values. All right, let's see here. So here, I want to talk about a variable naming thing, right? So let's say we had this class. We'll call it. Let's say it's going to have a first and a second integer variable, right? And we can set first and we can get first and set second and get second. And maybe we might have something like a sum method that adds the two together. We have a quotient method that divides the two. Okay. Now this compile. Some of you are asking about this. Do I have to have a main method? No, you shouldn't have to have a main method. I can compile this, right, with no errors. All right, no errors, even though it doesn't have a main method. Now, if I were to try to run it, I would get a problem, right? Because it would say, hey, you don't have a main method. That is the difference and running. Okay, compiling. Let's say I'm going to variable method, right? Here I'm going to create a new math stuff. First plus second. What's the sum? What's first? Okay, so I can compile that. And I can run. Okay, but I should see down here in my output, 100 plus 3 is 100. We know from integer division, right, that this results in integer division, so there's no decimal involved. Okay, now what I can do is I can come in here and I can say I don't really like this. I want it to be A and B. Okay. Now I'll have to go through and change it. Second is B. All right, so as long as I change it in all these places, which might be a bit cumbersome, but right, then guess what? I've named them A and B, but my methods are still called get second, set second, get first. This will still work. Should, let's see, did I get any error message? No, see, it still compiles, right? And here, if I come over here and I run it, it still runs the same thing. So this still runs the same way, even though I changed the variable names, the method names are correct. All right, that's all that matters for this program, this main method here. So imagine that this main method was kind of like our test method for your code. The only thing that matters is that you get this. We don't care what your variable names are. We care what your method names are. Now, let me rephrase that. The compiler and the executor don't care what your variable names are. If you give us variable names like A and B, which we made very clear back in 101 was not a good variable name, right? Then you may get points taken off because you didn't follow the coding standard, right? But whether you call something a local variable AKTC or AKTC or AKTC, it doesn't matter. Like as long as you keep that consistent throughout. So you notice that I had to come through and change A and B. Notice I didn't have to change it here though. I didn't have to change A first here. I could. I don't have to. Right. The only thing that matters is that this first is going to be put to this variable here. This dot A is saying the variable A inside of my class. Okay. All right. Let one other thing. All right. So, and we can change what our math stuff starting values are, right? So we could say 303 instead of 3 and 3. All right. So now 300 plus 3, 300 divided by 3. We could change, let's see. First, rather to be here we're going to compile this. We run it. Oh, we got runtime error. Huh. Okay. Anyway, so we started off with this 300 for first, 3 for second. We got 303, 100. Then we changed it to 0, and we got 3 and 0. Yeah, I may need to move to a different room. All right. Okay. Let's try maybe moving to a different room, but let me just finish this one off real quick. So then we have 0 plus 0 is 0. That was this print line. And then we ended up with a runtime error. Okay. All right. So I may try to real quick. Let me try to move to a different room. All right, let's see if that's any better. I hope that's at least a little bit better. Okay. And hopefully maybe even the recording is better than what you guys are hearing live. So that was the discussion on so the way that whole variable naming stuff can work. Let's go ahead and where were we on this? So we were this. We talked about overriding, overloading. Talked about the toString method. Okay, let's start here. All right, so the other part of what we talked about, so the other side of what we're talking about here, in addition to inheritance, is also this whole concept of polymorphism. Okay, and basically what we're looking at is that an object of a certain type, will be considered also its parent type. So what we're saying in this is a person is an object. So remember, if we think back, well, I guess it's down here over here as well. So we have a class called person that extends object. This extends object, as we talked about last week, is unnecessary. Automatically, if you don't have the extends keyword at all, it automatically understands that it is extending the object class. Okay, now we have this thing called a person, right? That's of the object type. Now, then we have a class called student that extends a person. So don't let your other professors tell you otherwise. A student is a person, okay? I'm telling you now, a student is a person. All right. So in this example, everything that belongs to person, everything, all attributes, all methods, the student class will gain those attributes and those methods. Now, what we've done here, what we've done with the toString method is we overrode, or we did what we called last time. We override a method when we override a method. So the toString method exists in the person class. And what we're saying for the student class is I don't want to use the toString method of the person class. I want to create my own toString method. Okay. Now, graduate student extends student. So the way we would read this is a graduate student is a student. So again, everything that belongs to the student and everything therefore that belongs to the person also belongs to the graduate student. Now notice there's a difference. We didn't override the toString method here. We didn't create our own toString method for graduate student, which means on its own, graduate student gets the toString method from the student class. Okay. Now remember, one thing we said last week was that the toString method is an example of a method that exists in the object class, and therefore it exists for all classes that we write in Java. So what that means is that this will not result in a compiler error, because the object class does have a toString method. So therefore, when we do this, when we call this with a graduate student, when we call the M method with a graduate student, it's going to access the graduate student's toString method. Well, guess what? There is no graduate student toString method, so it will look to the parent student and it will say, oh, there's my toString method. I'm going to use that. Then we're going to call the M method with student, with a student object. It's going to look for a toString method in student, find it, and use it. Then we're going to call the M method with a person object. We're going to call the toString method for the person object. It's going to say, hey person, do you have a toString method for me? Person's going to say, yes, I have a toString method, and it's going to give me this value. And then finally, we're going to call the M method with the object class. And what's going to happen? X is going to be called its toString method. It's going to look into the object class, which we don't have direct access to see its code, but there is a toString method there, and whatever its value is will be returned here and printed. Okay. One thing to note, notice here in the void M method, we can say I'm going to take an object, which means I can take anything into this X variable that's a type of object or a child of the object class. Well, person is a child of the object class. Student is a child of person, which is a child of the object class. Graduate student is a child of student, which is a child of person, which is a child of the object class. So therefore, all four of these things are considered to be an object. I would not be able to call this method. I would not be able to write this method, M, saying give me a person X. Because if I did that, calling it with an object would result in an error. What type of error do you think it would be? We'll look at it as an example. What time is it? Yeah. Let's look at it as an example, and we're running up close to a break time, and I know we started a bit late today, but this is such an important concept. This is such an important concept. I want to make sure that you guys see it. Okay. I need to share this. Is the order of the class important when a class extends? If what you mean by that is, Tarana, if you mean, does it matter if I say class person extends object, or let me go down one level below that. Class student extends person? Yes, because if I say class person extends student, then it's meaning I want person to get everything from student, okay, which is the wrong order, right? So when I say class A extends B, whatever A and B are, when I say class A extends B, I'm saying B is the parent and A is the child, and anything that B has, A will get. Okay, so let's take a look at this example here, this dynamic binding example. Question. Harrison, there really isn't. You can if you can explain why. I don't really. I did it using a long, so it's perfectly fine to use a long for that. But if you understand why big integer, we are going to pass a long primitive data type into your method. So if you use big integer, you may end up with compiler errors on our end, which would mean a lower grade for you. Okay, so just putting that out there. Emre, it shouldn't be larger than long. Let me see. The max value for a long in Java. I'll share this with you. So this, I don't think your student number is larger than that. Right? I don't think your student number is more than 3, 6, 9, 12, 15, 18, 20, 19. I don't think your student number is larger than 19 digits. So this is the largest value that a long in a Java can take. Right. You go ahead and do a Google search on that, because a couple of other students have had that same question. Go ahead and do a Google search on that, and you'll have an answer. Okay. Where was I? And I'll just say where I found it for one student was where I found it when I was trying to help a student was Stack Overflow. So let's see, where were we here? Okay. All right. Let's. Wow, this has got a lot more to it than I meant. All this stuff is right. I'm gonna go back and do this the same way that the slide shows. I think I did some stuff here. Comment that out. We'll come back to that in just a moment. Let me do. All right. So now I'm going to put a debug stop here so that we'll get there and then we'll stop. Okay, so now we're going to call the M method with a new graduate student object. Okay, it's going to create a new graduate student. It's just going to create a new student. Okay, and now it's going to print my toString method in there. All right, and what's the toString method for the graduate student? Well, it doesn't have its own defined, like I said, so it's going to look to its parent student. And because there is one there, it's going to say that's what I should do. So it's going to return the string student. This method's going to display that word, that student word, and then we're going to move on. Okay. Now we're going to call it with the student object, with a new student object. Okay. And then we're going to call the print line with the toString method of this. Well, X is a student object this time. All right. So it's going to return the word student. It's going to print out the word student again. All right, and it's going to move on. Now we're going to create a person. And we're going to call this with now this time notice X is now a person. Notice we don't go to the student's toString method because we're in a person object. So person, it's going to call its toString method, and it's going to say person. All right. Now we're going to call it with an object. Notice we don't go into the code to create an object because we don't have that code available to us. So when we call the toString method for the object class, we get this. Right? Remember, there's a native toString method for every object. Right? So a couple of things that I want to point out. If we change what we call our method, let's say we even just change this to a lowercase s. All right, we'll get a compiler error, right? Because it will say, come on. Oh, hey, I can't find that. I can't find that too. Oh, well, here, let me do this. Let me get rid of that. Let me change that to lowercase. Right, that should do it, right? And here's the problem. It's still getting that error, and the reason why is because this method does not exist in the object class. So what I could do is I could say, so what if I say, okay, well, don't create an object. I'm just only going to create these things, right? I'm only going to create these things. I call it here. Oh, I'm gonna have to change it here too. And the reason why was because if this stays an object, then it's going to expect that anything that could be an object X could be anything that could be an object. So I need to make sure that this method exists in the most parent class of whatever this is. Okay. So if I say, okay, make this a person, and that should do it. Right. Because now what I've said is person, I know that this method exists in the person class. Right here in the person class, and it exists, and even though it's overridden in its children, it at least exists here, which means it's going to exist for all of its children, even if they don't write a version of it for themselves. Okay, so if we run this, now we got student, student, person. Okay. One more thing I want to show, or maybe I have time for a couple more things to show. If I uncomment this line, and I just change this back to capital S because I want to make sure I'm using the correct toString. Okay, I'm going to still get an error. Right here. And the reason why is because when I try to call M with an object cannot be converted to person. I'm trying to take an object and put it into a person variable. Now, it is possible that something might be a person, that an object might be a person, right? But the compiler doesn't know for sure. The compiler doesn't know that this thing will be a person for sure. So like if I did this, try to compile this, I'm going to get the same type of error. Maybe this is a better way to understand it. Person cannot be converted to student. So I cannot put a person object into a student variable. Okay? Because a student is a person, but a person is not necessarily a student. Okay. So hopefully that's pretty clear. Hopefully you guys understand why that is, why a person is not necessarily a student, but a student is a person. So if I change this back to person here, and I try to compile it, I should get no problems now. Right? Because now I know there's no line of code here where I'm calling this method m with something that isn't some type of person. It could be a person object, it could be a child of person, it could be a child of person. Okay? All right. So up here, we're not going to do this just yet because I realize this is implicit and explicit casting, which has to do with, like I said, sometimes a new person object might be a student object. We might want it to be a student object specifically, but it may not know that. So we can do what's called explicit casting. We'll talk about that on the next set of slides. After the break, the next slides we go over after the break. Okay. All right. Are there any other questions? Okay. All right. So I will see you guys after. We'll take a break for 10 minutes. I'll see you at 2:33, 2:34.